question asks us to convert a hybrid structural formula into a line angle structure. The first thing we should do is number our carbon atoms. You may have numbered yours a little bit differently than mine. Doesn't really so much matter as long as we both get to 11 carbons. With that, we can start with our line angle structure. We start with our bond between carbon 1 and carbon 2. Let's go ahead and label those carbons. Next, we have the triple bond between carbon 2 and 3. A triple bond is comprised of sp hybridized carbon atoms, and sp hybridized carbon atoms have a 180-degree bond angle and are linear. When we draw a line angle structure of an alkyne, we must respect that linear geometry of the alkyne. So I'll draw the triple bond to carbon number 3 as a linear bond with carbon number 2. I like to leave a little bit of a space between the single bond and the triple bond just so I'm very clear about where carbon number 2 is. I'll do the same thing with carbon number 4, adding a bond to carbon 4 that's also linear. From here we have bonds to 5 and 6. We can put those in our regular zigzag orientation. Attached to carbon 4, we have the 2-carbon chain for 7 and 8 and the 2-carbon chain for 9 and 10. By convention, we draw substituents on the convex side of line angle structures. What I mean by that is we draw the substituents on the pointy side of carbon number 4 and not the concave side, not the interior of the carbon number 4. Same thing with carbon number 11. It's attached to carbon number 5, so by convention, we'll draw it on the convex side as well. And these are the 11 carbons in this structure, and this is the line angle structure for this hybrid structural formula.